All right, we are graduating from the independent samples t-test to the one-way ANOVA, or analysis of variance. With the independent samples t-test, we are comparing two independent groups on one dependent variable or outcome. With a one-way ANOVA, we have more than two independent groups. On the first lecture example, we're looking at differences between liberals, moderates, and conservatives, three independent groups, on one outcome, that is feminist prejudice. We already saw with the independent t-test that conservatives reported a lot more feminist prejudice than liberals. But we want to know how liberals differ from moderates and how conservatives differ from moderates. And that's where the one-way ANOVA comes in. So we're going to go to Analyze, General Linear Model, Univariate. We're going to put our dependent variable in the dependent variable box, which is prejudice toward feminists. And then in the fixed factor box, we're going to put political orientation. So we're looking at the effect of political orientation on feminist prejudice. We're assessing whether feminist prejudice depends on your political orientation. That is, whether you identify as liberal, moderate, or conservative. We're going to go to post hoc. Now we're going to bring our independent variable over to the post hoc test box. And we're going to click Bonferroni. So as we discussed in class, if we get a significant F value, if the overall ANOVA test is significant, that means there is a significant difference somewhere between the groups. And post hoc tests or multiple comparisons will help us identify which groups actually significantly differ. Under Save, we're going to click on Cook's distance. Cook's D will help us identify potential outliers that are unduly distorting our inferential results. Under Options, we're going to click Descriptive Statistics, Estimates of Effect Size, and Homogeneity Tests. And then paste, and then run. So first thing that you want to look at is the Cook's D values. So every participant gets a Cook's D value, and we want to sort these descendingly. If you run multiple ANOVAs, you'll get multiple Q columns. So if you run another ANOVA with a different dependent variable, you'll get Q2, Q3, etc. So every participant gets a Cook's D value, and remember this Cook's D value reflects how much the participant would be, how much the participant affects our inferential results if they were removed from the data set. So bigger Cook's D values indicate, or I should say, the bigger the Cook's D value, the more likely it is that a participant is an outlier that is unduly distorting our inferential results. So what we're looking for is big Cook's D values, actually big jumps in between the numbers as we go down the column. Here we see a nice progressive decrease from 0.05 to 0.04, 0.03. So it doesn't look like we have any participants that are potential outliers. If we saw something like 0.6, and then to 0.05, we see a huge jump here. And this would indicate that number 68 here, participant 68, is a potential outlier, and we would want to run the analysis with and without number 68 and see, compare the results to see how the results change with and without number 68 in the results. It is sometimes possible that your results will become significant or become non-significant just by removing one participant. So it's very important to check for outliers here. But our Cook's D values look fine, so we can go and start looking at the output. So we get a lot more boxes than we would with the t-tests. So let's sort of just go through them here. We have our descriptive statistics box that gives us the mean, standard deviation, and n for each of our independent groups on our outcome here, prejudice toward feminists. And then we get our equality of variances, Levine's test. So we want to make sure that we meet all the assumptions for our one-way ANOVA, which are the same as for an independent t-test. So we want to make sure that we check normality of our dependent variable, which you already did a couple weeks ago. So we check to make sure that the prejudice toward feminist distribution approximated normality. We also want to check equal cell size for our independent variable. And as we just take a cursory glance at our n's for our independent groups here, we can see that these are these are equal enough that we will be fine. But we could do the hand calculations, take the smallest n, multiply by 2, again by 3, and make sure those products are larger than our largest cell n here. So if you multiply 35, the smallest n, by 2, that would give us 70. 70 is way bigger than the largest n here, 45. So we'll definitely meet the equal cell size assumption. And then we'll check Levine's test for equality of variance. Levine's test here, we check the significance. It is 0.92, which is non-significant. So that means we meet the equality of variance assumption. Again, if Levine's test is non-significant, we meet the assumption, we move on. If it was significant, then we would want to do the hand calculations to make sure our standard deviations are not meaningfully different. But since Levine's test is non-significant, we can move on to the ANOVA table. Again, ignore the rows for the corrected model and intercept. You want to pay attention to the row that has your variable, your IV name. So here, political orientation. And we look over and we see I have an F value of 9.24 and a significance of less than 0.001, P less than 0.001. So we have a significant F value, which means that there is a significant difference somewhere between our groups on prejudice toward feminists. And this should not come as a surprise, given our independent t-test showed a huge difference between liberals and conservatives. But before we look at the post hoc test, the multiple comparisons, just want to briefly talk about partial eta squared and r squared here. So partial eta squared, which in this case is 0.134, tells us how well or how much our independent variable predicts our dependent variable. So how much political orientation or how well political orientation predicts prejudice toward feminists. So we can turn this into percentage and say that political orientation explains 13.4% of the variability or differences in people's scores on prejudice towards feminists. R squared down here tells us how much collectively all of our predictors or all of our independent variables, how much all of them collectively predict prejudice toward feminists. As you can see in this case, partial eta squared for our independent variable equals r squared. They're both 0.134 because we only have one independent variable in this case. If we add a second independent variable, if we added, say, gender to the mix and looked at differences between men and women, then our r squared would reflect the collective contribution of both political orientation and gender in predicting prejudice toward feminists. So that will be the next step after one-way ANOVA. We'll add gender to the mix, and it becomes a two-way ANOVA. So r squared, partial eta squared, they are effect sizes. So they're trying to give us a sense of how large the differences are between the groups. All right, so we'll go to the multiple comparisons or post hoc test box here. And we're looking at three differences here. We have liberal versus moderate, liberal versus conservative, and moderate versus conservative. Again, there is some redundant information here. I don't know why SPSS does that, but it does. So if you look at the liberal moderate comparison here, which is one of the comparisons that we're most interested in, we see that the significance value is 1, so it's a non-significant difference. If we look at the difference between liberals and conservatives, the p-value is less than 0.001, so we have a significant difference between liberals and conservatives. That should not come as a surprise, given that we found with the independent samples t-test a large difference between liberals and conservatives. And then if we look at moderate versus conservative, the p-value is equal to 0.001. Pardon me. That, I should say, the liberal-conservative difference here, that is equal to 0.001, and then the moderate-conservative difference is equal to 0.001. And if we look at the means here, we can see that conservatives are scoring significantly higher in anti-feminist prejudice when compared to both liberals and moderates, but there's no significant difference between liberals and moderates here. So it seems like conservatives are scoring a lot higher on anti-feminist prejudice compared to liberals and moderates. Of course, a significant difference does not equal an important difference, so we want to make sure that we calculate our Cook's D values. And Cohen's D are effect sizes. And so we're going to calculate Cohen's D for each of our 3 differences, or 3 comparisons here. So Cohen's D, just like for the paired and independent samples t-tests, we're going to take the mean difference, the observed difference, and divide by the pooled standard deviation. In this case, we have 3 standard deviations from 3 independent groups, so we need to pool these, or average them together, but we need to weight the standard deviations by how big the groups are. So as you can see, we have a lot more, well, I shouldn't say a lot more, but we have more moderates and conservatives than we do liberals. So the weighted average standard deviation should be closer to those of moderates and conservatives, because there are more people in those groups. Now, we just don't want to go to the Lion Morris website and enter 2 groups at a time, because we want to find the pooled standard deviation across all 3 groups. That will give us the best estimate of what the population standard deviation is. So luckily enough, you can calculate S pooled, the pooled standard deviation, very easily. So in the ANOVA table, you want to look for the mean square error here, which is 3.48. All you have to do to get S pooled, the pooled standard deviation, is to take the square root of this number. And that should give us, let's check here, should give us square root of 3.48 is 1.87, and then to calculate the D for each of the comparisons, we'll just take the mean difference from the multiple comparisons table and then divide each mean difference by 1.87. And that will give us the D's for each of our comparisons here. As you can see, the D's for the liberal versus conservative and moderate versus conservative comparisons are large. So it seems like conservatives are reporting a lot more feminist prejudice, or conservatives are reporting a lot more feminist prejudice when compared to liberals and moderates. But there is no difference between liberals and moderates. So yeah, so just adding one group, having 3 independent groups, does make the analysis a lot more complex. But hopefully this video will help you in this endeavor in tackling the one-way ANOVA.